Let's take this equation and solve this problem. So this problem says that a baseball is hit off a bat at 45 degrees. Its initial velocity is 135.76 feet per second, and the baseball is approximately 3 feet above the ground when it's hit. So we're also going to use gravity as 32.2 feet per second squared. We're going to ask, how high does the ball go? What's its maximum height? When you're talking about maximum height, this doesn't matter. This is the only side that matters. But regardless, we're going to take the derivative of this thing, because when the derivative of this thing equals 0, that means it's at its maximum. All right, so let's look at that. So let's take the derivative of this thing. This would be dr dt is going to be equal to velocity initial times cosine theta, and then the derivative of t is just 1, so that's going to be our I direction, plus, let's look at h. Derivative of h is going to be 0 plus velocity initial times the sine theta. Derivative of t is just 1 minus 1/2. The derivative of t squared is going to be just t with the 2 out front, so this is going to be just gt. So we're going to have this g times t in our j direction. Alright, so now what we got to do is find out when this thing is 0. Well, we'll just put this in here then. Velocity initial, sine theta, minus gt is going to be equal to, equal to 0. And then we have gt is going to be equal to velocity initial, sine theta, divided by g is going to be equal to our t. Alright, so the negatives go away. So this is going to be our t. Plug those numbers in. Velocity initial is what? 135.76 feet per second times 1 over 2 square root divided by 32 feet per second squared. Oh, that's going to be so nice. It's going to end up just being time. This is going to end up being seconds, which ends up being 3. Once we do all the calculations, it ends up being 3 seconds. So t is equal to 3 seconds. Let's put that up here. So at this point, the t is equal to 3 seconds. So that tells us what time it is when that happens. So to know how high it is, we can just plug that back into our equation here. We can put 3 back into our j direction to tell us how high the thing is. Actually, you can put it in here as well. Anyway, so let's put this in here. So let's put our 3 in here, 3 seconds in here. We have h is 3 feet. 3 feet plus velocity initial is 135.76 feet per second times 3 seconds right here. We're putting this here, and then minus 1/2 g. So I might as well just go ahead and do 1/2 g, 1/2 g, which would be 32 feet per second squared times our time squared, which would be 3, which is just 9 seconds. All right, and this is going to be equal to our max height. Our max height. Let's do some mathematics here, and we find out that max height is going to be equal to approximately about 147 feet. Nice and powerful. I mean, this equation is just pretty much will solve that rather easily for you. Let's see what happens at x at 3 seconds. So now we know this is in the y direction, so we know our max is 147 feet. 147 feet in this direction, right? From here to here, all the way down to the ground. Let's find out what it is in the x direction. So how many feet is it from when the ball's hit to the fielder out here, so to speak? All right, so then we would just plug 3 seconds into our I direction. So this would be x in the I direction is going to be equal to what? Velocity initial 135.76 feet per second times our time, which is 3 seconds. And then we're going to see that that's going to come to equal. So this is in the x direction. It's going to come to be 287.95 feet. 287.95 feet. I would say this is probably a home run ball. That's a pretty far distance. That's a pretty long distance to go. So the person who hit this ball is most likely going to hit a home run. Okay, so what does this RT mean? What does this actually mean? Let's look at this. So let's think to ourselves that this is our X, this is our Y, this is our Y direction, this is our X direction. What does R of T mean? Well, if this is 287.95 feet and our maximum height is 147 feet, right? This is our maximum height. Right here is R of T. This is exactly what R of T is telling you what it is. R of T is this thing right here. From your origin to here is R of T. All right? Even though this is 3 feet off the ground, still this is our R of T. We could find out what the value of R of T is by taking what? You would add these together vectorially. Right, so R of T, probably have to get my calculator out to do it. So R of T is going to be 287.95 feet squared plus 147 feet squared. And then we got to take the square root of that thing. So R of T would probably come out to be, I think once you do that, I'll use my calculator. 287.95 squared plus 147 squared equals square root, about 323 feet. 323.3 feet. So that's our RT. This is what that literally means. It means that's how far away the ball is from the batter. So this is actually telling you that the ball is 323 feet away from the batter, or away from when the ball hit the bat, right? It's not this and it's not this, but it's rather this direction. So this is what R of T actually means. So keep those straight. And then we're going to try to find out how far down range it goes. Let's look at our range, see how far down range it goes. That would be when this would end up being 0 again. All right, so let's look at this. Let's find our maximum range. Probably the easiest thing to do is find out the maximum time. We can do that by simply finding how long it takes for the ball to drop from here to here. Probably the easiest way to do that is find your velocity final. Using our kinematic equation is probably the easiest way to do it. I would say that velocity final squared equals to velocity initial squared plus 2AD. Right? We would find our velocity final. If you put in the numbers, I'm not going to do it because it takes too long. This velocity final ends up equaling 97.3 feet. So this ball is going to come down and hit the ground right here at 97.3 feet in the Y direction. So this would be 97.3 feet per second in the Y direction. So we're going to have the ball be in this direction, going downwards. And then that takes about, once we solve that, then we can put this into velocity final is going to be equal to what? Velocity initial AT, right? Then we just find T. T is going to end up being 3.02 seconds. All right, so that means about 6 seconds. Well, then that means if we put 6 seconds into this thing, we should find out how far down range this goes. Well, just put 6 seconds into your I. Let's do that. R of T, 6 seconds equals velocity initial cosine theta times T, right? So our R of T in the I direction is going to be equal to velocity initial is 135. Whoops. 135.76 feet per second cosine. Whoops. Times 1 over 2 square root times 6 seconds. And R of t ends up being, once you do this, R of t ends up being 578 feet. 578 feet. Wow. 578 feet. That's definitely a home run. So from here to here, from when the ball was hit, from here all the way to here is 578 feet. Yeah, that's definitely home run material right there. I think Babe Ruth in 1921 hit 575 feet in 1921. Right, Babe Ruth. So, if you think about this, we've just sort of imitated what Babe Ruth did in 1921. So basically, we can say with pretty much confidence, not total, but pretty much confidence, that when Babe Ruth hit the ball in 1921 that went 575 feet, he approximately hit it at 45 degrees and at 135.76 feet per second. If it would have been less of a degree, he would have had what? A greater velocity. If it had been a higher degree, it would have been less velocity. So I would say probably this is probably pretty close to what happened in 1921. That's kind of neat. That's the nice thing about physics. Physics can tell you things about things that happened 100 and some years ago. Anyway, I hope that helps you to understand exactly what this means and exactly how this equation can be used. It's a very powerful equation. It can be used in many, many situations. G doesn't necessarily have to be gravity. It doesn't necessarily have to be in a negative direction. It could be pretty much anything. It's a very nice equation. Hope that helps you. Please subscribe.